Anyways, good afternoon, everyone. Some sexy faces in the audience as well as on the screen. Just to run through a little agenda, and you saw that there was, let me try to distance a little better. The first half of this presentation was actually worked through by Chris Grendeman, who did a survey and I'd say dozens of interviews. So I'm going to kind of fumble through that because we use that as a basis of a lot of the things that come after that, which is more technical and my area of expertise. And also, as a just heads up, is like I said, there's a lot of things that I've learned personally. There's things that he learned. There's things that he maybe has talked to a lot of the people in the audience about where they're at. And everything we're doing is either open source now or moving towards open source. And I think Tom just gave a brief intro to me. This is my first time doing a talk that I didn't write, and my first time with my picture on a talk, so I can skip past that pretty quick. I think one thing that I'd like to point out is last time I was at CHI-NOG was for CHI-NOG 06 when I was building something called the Chicago Internet Exchange and using automation for that, and I'll get to more of that later, but I thought this might be a good follow-up because this is kind of a culmination of a lot of that work. And I think we're entering into kind of a new age of automation. I know when I was starting the Internet Exchange before, it was primarily carriers. It was kind of almost niche, and the BGP isn't for everyone, and it was a lot of people that don't know BGP, don't like BGP. Like, BGP is hard for a lot of people. There's a lot of areas that it's not standard at all. Like everything's kind of, everybody's network. There's a lot of organic growth, I should say. And everybody's network's a little different. Everybody's network needed to work a little different. And because of that, there's a lot of lack of automation. Although, almost 10 years later, there's a lot more automation. It's still probably not as much as I would have expected if you would ask me back then. That said, and I think a lot of people have mentioned this and brought this up, is peering is kind of dead. A lot of people don't believe in that. I'm kind of on the fence. The cost of transit has dropped so much that one can make a pretty solid argument if you're just going into random internet traffic that you don't need pairing. Like the latency is nice, but with the latency, lower latency also comes headaches. But the one thing that kind of changes all that is nobody's running their own data centers anymore. Very few people are. Everybody's using something in the cloud. So this new age of interconnection we're entering is, how do I get to my stuff in one of the big cloud providers? Like, how can I get to that efficiently? How can I manage that? Because my infrastructure it's sometimes running there. Whereas before, there were things like SD-WAN and large MPLS networks to connect different corporate offices and things like that. Now it's pretty much in the cloud, and obviously there's not all the time, but a lot of places there are. And while it's in the cloud, you lose some of the benefits of being directly connected or having total control over it. So this new interconnection is actually connecting to somebody else's network, but the services running on somebody else's network are essentially your own. And we get back to BGP, which for many is a four-letter word. I think there seems to be a lot of tribal knowledge in the BGP area. There's a lot of people that are very scared of it in enterprise, public sector, small businesses. Like I said, it's traditionally been a carrier thing. WISPs, co-ops, like a lot of people are just dumping their IP where they can get to dump it because the IP is not their business and the routing is not necessarily easy enough and turnkey enough to make it a good focal point. And we now have things like RPKI, and you need to know some cryptography to make sure your routes are announced across the internet. You need to worry about hijacking, things like that. So there's a lot of things that cause the networks to be different. Like I touched on that a little before. We've been kind of shooting around an idea that we're thinking that the modern, let's say, BGP and network interconnection is a lot like the manufacturing and industrial in the 18th century, 19th century, whereas everything was handmade. There wasn't assembly lines. There wasn't like the cookie cutter thing coming out. So if you bought like a musket, it was all handcrafted. So if something broke on that, you had to go to a craftsman to do that. And we're kind of in a similar place with networks where it really should just be I want this traffic flow to go from here to here. Like some part of me wants to say, how is it possible in 2023 that people are still even thinking about this? How is it that we can have a bot that we talk to online that tells us what to cook for dinner, with what's in our fridge, but we can't have it how to get a bit from A to B? Like, this is simple. But that's a tangent. There's a lot of different communities and used by different networks. So anytime you touch traffic engineering, which is needed, there's a lot of customization that needs to be done. And then just the whole interconnection coordination, LOAs. I'm sure everybody hates LOAs in this room. Which gets us to the automation. When you have things like that, it's pretty hard to automate. Not impossible, but pretty hard. Almost nobody Chris talked to has gotten to the point where they're like, nope, we got enough automation, we're done. Everybody's still got one more thing they want to automate for the people at the top end of the curve, and the people at the bottom end of the curve are still struggling with, well, I don't even know where to start automating, or where can I do that? Lots of places still don't have a de facto source of truth in place, and a lot of this is kind of, I guess, expected with the lack of standards. When you're dealing with your custom-made network that touches 8 different things, it can be hard to jump in and figure out where to standardize, where to normalize, things like that. On top of the fact that even with where we're at in terms of like virtualizing a lab setup, it's still not easy to get a lab turned up, and without replicating maybe your whole production environment, it's pretty hard to get the confidence to rip out and replace everything you're running. And I guess this is no longer a sneak peek because this is over, but of all I'm trying to see if there's a count on all the networks that took the survey, but I want to say there was a few dozen at least. You can kind of see where the left side is nothing is automated, the right side is everything is automated and nothing is done manually, and nobody even hit the top 2 on that for what they claim. This is all just what they claim, obviously. So you can see a lot in the middle. One of the things that I think might be too small to see here, which we found interesting, was the blue is the majority of the people. Do you consider yourself a networking expert? And most of the people said that. Hard time seeing this. And then when you go to interconnection expert, still a majority, but not as many people. And then when you get to what about an automation expert, almost nobody was there. So I think there's still a lot to go to, I guess, to grow. So like I've said, I was last here talking about how I was automating an internet exchange, and I started automating before I had even plugged in a device. And both of those things at the time people thought were questionable. I'm still happy I did it that way. I still thought it was a pretty big benefit. One of the things is I have a Git log of every topology change from when we started the Chicago Internet Exchange until now. It all started as a subdirectory of a deploy script in an Ansible repo someplace called UIX Auto, because it was the United Internet Exchange. And then there's still pieces of that in IX Control. So as I was automating this, I started doing some side work on other automations and started seeing a lot of common pieces and breaking those out and use them here and use them there. And I always intended on open sourcing them, specifically with peer control, which manages our peering stuff. And I never quite got around to it. And at the time, I couldn't figure out why nobody else was doing it. I couldn't figure out, honestly, not only why weren't they doing it, but maybe it wasn't necessary, which kind of goes to, if transit's going to be so cheap, do you really need pairing and the headaches that come with it? And also just that there was almost no chance at the time of trying to get seamless automation between ASNs, so different companies doing like a protocol or whatever. I know Tom had talked to me way back then about there where Tom was like, nobody's doing this, let's do it. And I remember saying something similar to, that's great, but try to get anybody else to do it. Like, you and I can decide to do it, but that's not going to be anybody else. And I think now, finally, there's a lot of people making progress in that area. So then, kind of getting to the point, you can see our naming theme here. And control, by the way, this abbreviated TTL is a pretty old school Unix command, and we follow the Unix philosophy very, very strictly. So we started kind of piecing things into, well, can be used to control an internet exchange. This can be used to control peering. This can be used for my peering or prefix database, things like that. And started talking to people, and then started pulling these out just last year. Just started pulling these out and actually open sourcing them, and some places digging into code that's almost a decade old, but still seems to be unique in what it does or how it does it. Which brings us to our full control suite, which is all open source. With the prefix control is not open source yet. These are just chunks of software designed to be modular, like I said, the Unix philosophy, so everything does one function and one function only. It's quite modular. You can run individual pieces if you want. It's 100% API driven from the start. In fact, if anybody takes a look at this, the UI in some, if not too many cases, is pretty bad. But the API is pretty nice. And the whole goal of this is to automate interconnection and be used as a source of truth for wider automation efforts, which is to say that we're trying to really focus on how to automate interconnection. There is many, many solutions on how to do standard network infrastructure. The foundation to probably hold everything in is the AAA control, which is just like you'd imagine on a router. It controls authorization. It's designed to function both as a client to your corporate Active Directory or any other one. PeeringDB is a great thing to use to authenticate against. And then it integrates with any of the services you run under the umbrella. It's got very granular permissions, and everything's audit logged. So every time somebody accesses something in your source of truth or anywhere in your networking stack, it gets logged so you can see what happened where. I think I just talked about all of that. It's all role-based for the most part. It's pretty much drop it in and use it for an auth source. Device control is another one of the foundations. It's what we use for devices. Since again, like I said, we want to do one thing well and we don't want to reinvent the wheel, so this is designed to pretty much use one of the many other solutions. It works quite well with NetBox. We definitely send Nautobot. We have customers using proprietary systems that are the actual source of truth for their network. You can point it at PeeringDB to grab things out of there. It caches them all locally, so if anything goes down that you're using from a different system, you still have that data available. I was just talking about earlier, I was delayed because GitHub was down. That's a perfect example of something that rarely ever goes down, but guess what? It happened to go down while I was doing a deploy. And while my stuff didn't use GitHub, my dependencies did, because other people use that as the source of truth for their software. So we always want to keep everything cached and under our control if possible. Prefix control is the same thing. It's quite useful for managing any of the prefixes you control. It can do sync with any IRRs, or many of the IRRs. It can update RPKI status. We have IP reputation plugins, so you can do things like query for your IPs are on any lists. If somebody's reported it as a bot, if it's getting spammed, geolocation data, things like that. And then on to the fun stuff, or what I consider the fun stuff, which is IX control. So this is basically the building blocks for automating an internet exchange. And it starts with just kind of all the key parts, the foundations that I discussed, and then adds on all the things you'd want to do when running an IX, which means allow for member networks to do things like one-click update or add a session to your route server to change how the traffic works, one-click to update their MAC address because they pull the line card. And for those of you who are not aware, like most IXs will do MAC address locking, so not anybody can plug into the fabric. And one of the biggest problems with that is when you replace a line card at 2 a.m. and your traffic no longer routes and you get done with your maintenance and you really want to close everything out, but you have to wait for somebody to change your MAC address. So lots of little things like that mostly for IX operators, but the networks that peer on exchanges definitely will appreciate them as well. It does turnkey route servers. So another thing is, maybe take a step back, a route server is essentially a directory for BGP routing. So if you connect to a route server as a network, you can get the routes from any other network connected to that route server, but you get to take the routes directly to the neighbor. So route servers are quite useful in internet exchanges. They're sometimes pretty hard to make secure, and this does that for you. And I'm kind of breezing past this more than even the rest of the stuff, since I don't think anybody in this room really cares much about how to run an IX, but I guess maybe I'm wrong. Just show of hands on people that like IXs. So there's a couple out there. This is all designed, like I said, it's all modular, so we have Ansible scripts to run it on, things like Docker or Podman. We run it natively on Kubernetes. And it manages configs, so you can build anything you want. And you can, like I said, everything's API driven, so there's an API for everything. In a lot of cases, you can access the APIs from curl quite simply, because we have a lot of people that like to just add a curl command in their bash script that does X and everything's good. So, excuse me. That's one of our main features on our IX software is the route control handling, route server handling. We also offer a full source of truth, which we just got through rolling out some new things for member ports that pretty much accomplishes or shows everything you need from a member port, or which physical hardware they're connected to, so you can build graphs, you can manage members. You can use this to control peering DB, which is the only way that an IX can actually remove or change a member on peering DB currently is through an API. So you have to have something use the peering DB API. This gives you a quick and easy GUI just to manage the peering DB output if that's what you need. And then member access, like I said. The new stuff we're working on, and I think you'll notice a general theme in what we're working on right now is portals, because it's all going back to, like I said earlier, is just let's automate interconnection between networks. So it's one thing automating your network, it's another thing making it easy to automate so you can connect to each other and make your network stronger and better that way. So a lot of the stuff we have coming up is for public portals, so you can actually go and click, yes, I want to peer at this network, and then go through criteria that maybe allow it all to automatically bring up a session without a person doing anything. And then the other main thing we have is Looking Glass, advanced route server configuration. So just kind of enhancing the things we have more. And then I have your idea here. Like I said, it's all open source. Patches are welcome. If you have a good idea, we can implement it too, depending on our time frame and whatnot. So we're always looking to hear about that. And then the other main thing is peer control, which this is the interconnection management. This does, peer is in the term BGP peer, so transit, iBGP, anything that you connect to with a BGP session falls under peer control. So we have some of the things available now is you can log in, you select an IX, it'll show you all the peers at the location that provide the BGP configurations based on what they say in PeeringDB, what they've reported in PeeringDB, what you've set up in your network. We have a series of overrides so it can load information from different points as a source of truth. Like I said, PeeringDB, it'll load anything out of PeeringDB, but you have the option to override it. So if you know that this network says they have 10,000 IPv4 prefixes, but you think they actually have more, you want to change that, you can override anything because you're in control of it. And then it's just got a lot of tools for showing you mutual exchanges for networks you want to connect to and things like that with their peering policy. This also has a public portal coming soon. So this is your source of truth for your interconnection. So you can define all sorts of different ways to look at your devices. You can also keep it completely off of your network and just use it for a source of informational truth that doesn't touch your routers. You can have virtual ports that you manage on your own, but just do interconnection through this with alerts saying that somebody wants to peer or whatnot. you can copy and paste config that this generates if you want to go that route. So it kind of has a little bit of something for everybody, I think. And it does have an email workflow management. So if you want to peer with a network, and it'll automatically make the email for you and say all the points that you're both at and would you like to peer, etc. If you do tie it into your network, you can get like essentially a show BGP summary in real time on your screen. You can pull in existing network sessions to this to manage them, things like that. Again, public portal is the biggest thing on our list right now. We have a lot of different peering DB integrations coming up. The UX improvements, like I said, the UX is, downright terrible. With advanced learning, though. So some of the new stuff, we're making improvements as fast as we can. And there is a full demo up if anybody wants to try it out. I think that covers it. Just a big thank you to the things on the list: PeeringDB, Netbox, Nautobot, BGP Q4, Global Traceroute, IXP Manager, Pairing Manager, Rancid. There's lots of other open source tools that we've used in part while making this, or contributed back to, or whatever. And we're just want to make sure that everybody knows that we're not saying we're the first or only people doing this. We're just trying to make things accessible for people. So, what did I do on time? Not bad. Any questions? Comments? Terrible remarks?
I think this is interesting. One quick question. So Brad was talking about RPKI and how some of the inter-exchanges, making it mandatory is helping with the implementation. Is that something that you're looking at, having RPKI support in this open source tool for the IXs to be able to implement?
Yes. So it currently is essentially a checkbox if you're running the route server, so it will implement it for you, which is what's the big thing we want. One of the next things that we want to work on that we really want to do is get it so that networks can manage their own RPKI securely. So we can get secure end-to-end, like essentially end-to-end encryption, with just allowing people to do it without needing to know how do you do it at Aaron and how do you do it at Ripe and everything else in between. So,
okay.
Yep.
Thank you.
All right. Well, thank you, everyone. Have a good afternoon.